Look closely at a modern toilet, and the strangest part is not the handle, the tank, or the porcelain. It is the small pool of water sitting quietly in the bowl. That water looks like nothing. It has no motor, no electronics. It does not even move until you flush. But it is doing one of the most important jobs in your house. It is separating the air you breathe from a pipe connected to the waste of an entire building, and often an entire city. Press the handle, and the rest happens out of sight. Water accelerates. Waste disappears around a bend. A hidden network takes over. Pipes join larger pipes. Gravity does most of the work. Pumps help when gravity cannot. Somewhere far away, screens, tanks, microbes, air, and chemicals begin turning what left your body into water and solids that can be handled without poisoning everyone downstream. That is why the toilet is a strange invention. The object in the bathroom is only the visible tip. Humans did not really invent the toilet when they invented a seat. They invented it when they learned how to separate themselves from their own waste, then move that waste, then stop it from coming back, and finally make it safe somewhere else. And those breakthroughs happened thousands of years apart. So how did humans invent toilets? The answer begins with a problem that did not matter very much when humans lived in small mobile groups. If a few dozen people move across a large landscape, human waste can be left behind. Sunlight, soil, insects, scavengers, and time do the rest. The simplest toilet is distance. Walk away from camp, find privacy, dig if necessary, and do not return to the same spot too often. Settlement broke that system. Once people built permanent houses, stored food, dug wells, and crowded together, waste stopped being a personal inconvenience and became an engineering problem. A village could not simply walk away from yesterday's feces. A city definitely could not. Every person produced waste every day in roughly the same place, while drinking water also had to come from somewhere nearby. That created a dangerous geometry. Mouths, wells, kitchens, animals, flies, and feces all occupying the same small patch of ground. The biological reason is brutally efficient. Feces can carry bacteria, viruses, protozoa, and worm eggs. They do not need to travel far. A fly lands on waste and then on food. Dirty fingers touch a cooking pot. Rain washes a pit toward a shallow well. A leaking drain reaches groundwater. One infected person can seed an environment that exposes many others. That means sanitation has a different logic from most inventions. A knife only has to work for the person holding it. A roof mostly protects the people underneath it. A toilet can appear to work perfectly for its owner while failing everyone nearby. If waste leaves your house and enters your neighbor's water, your toilet is convenient, but the sanitation system is broken. This is why population density changes everything. The more people share a small area, the more important separation becomes. Safe sanitation is, at its core, the engineering of distance. Distance between feces and fingers, feces and flies, feces and food, feces and drinking water. Pipes are only one way to create that distance. Ancient people did not need germ theory to notice the consequences. They could smell waste. They could see flies. They knew some places were foul and others were clean. What they did not know was that microscopic organisms could travel from one person's intestines into another person's food or water. So early sanitation often solved what people could see and smell without fully solving what could make them sick. The earliest archaeological evidence does not point to one genius or one civilization suddenly inventing the toilet. It points to several societies confronting the same urban problem. In Mesopotamia by the 4th and 3rd millennia BCE, builders were already constructing deep vertical drains and pits inside or beside buildings. Some were lined with stacked pottery rings that let liquids seep into the soil while holding back solids. By the middle of the 3rd millennium BCE, archaeologists find installations that look unmistakably like built lavatories, a place to sit or squat above a shaft with brickwork designed to guide waste downward. That sounds simple, because it is simple. And that was the breakthrough. A toilet does not need to make waste vanish. Its first job is to put waste somewhere human hands, feet, food, and living spaces do not have to meet it immediately. A hole in the ground with a stable platform above it can do that remarkably well. In many parts of the world, improved versions of that basic idea are still effective sanitation technologies today. At roughly the same broad period, cities of the Indus Valley were developing another solution at urban scale. At places such as Mohenjo-Daro and Harappa, houses were built with bathing areas, drains, and carefully laid brick channels. Wastewater moved through planned drainage systems rather than simply pooling beside the house. Some toilet installations emptied through vertical chutes or drains into pits and street-side channels. This matters because the innovation was no longer just the toilet. It was the connection. A hole serves one household. A drain begins to coordinate neighbors. A covered sewer forces builders to think about slope, flow, maintenance, access, and what happens when hundreds of households all send dirty water in the same direction. The moment waste enters shared infrastructure, sanitation becomes political. Somebody has to build it. Somebody has to clear it. Somebody has to decide where it ends. That last question is the one humans kept getting wrong. Other early societies experimented with the same ingredients in different combinations. On Crete, Minoan palaces and settlements developed elaborate stone and clay drainage systems during the Bronze Age. Knossos is often advertised as having an ancient flush toilet, but that phrase makes the evidence sound more modern and certain than it is. What survives clearly shows sophisticated water management, drains, and latrine installations. Exactly how every fixture was flushed and used is harder to reconstruct. That uncertainty is useful. Archaeology rarely gives us an inventor standing beside a finished machine. It gives us holes, pipes, worn surfaces, mineral deposits, parasite eggs, and buildings whose upper floors vanished 3,000 years ago. The history of toilets has to be reconstructed from what people left in the ground, sometimes quite literally. Ancient sanitation could be technically sophisticated and still fail biologically. One of the clearest examples comes from Iron Age Jerusalem. Archaeologists have excavated stone toilet seats in elite residences dating to the 7th century BCE. These were expensive installations. They belonged to people wealthy enough to have a private place to defecate over a cesspit. Then researchers examined what remained in the pits. They found parasite eggs, whipworm, roundworm, tapeworm, pinworm. Later testing also found evidence of giardia in sediments from ancient Jerusalem latrines. The people using those toilets had privacy, architecture, and social status. They also had intestinal disease. A toilet could make life more comfortable without making the surrounding sanitation system safe. The Romans pushed that contradiction to an extraordinary scale. In many Roman cities, public latrines had long stone or marble benches with openings set side by side. Beneath them, channels carried waste away. Water could run through smaller channels in front of the seats. Large bath complexes, fountains, aqueducts, drains, and sewers turned water management into one of Rome's signatures. To a modern visitor, it looks almost familiar. But familiar is not the same as sanitary. Roman public toilets were often communal spaces with little of the privacy expected today. Many houses still used chamber pots or simpler facilities. Sewer coverage varied. Waste could accumulate, and large infrastructure did not guarantee that pathogens disappeared. Studies of Roman-era latrines, burials, and coprolites show widespread intestinal parasites even in a civilization famous for baths and sewers. In other words, the Romans had moved surprisingly far along the engineering chain without understanding the microbiology at the end of it. They could transport waste. They could not reliably neutralize it. Romans also treated human waste as a material, not just a nuisance. Urine had economic value because ammonia-rich liquid could be used in textile processing and cleaning. Solid waste from cities could end up in fields. Reuse sounds modern, but ancient cities were already trying to recover value from what bodies discarded. The problem was control. Once waste became useful, people collected it. Once it became concentrated, it became hazardous. A material could be fertilizer in one context and contamination in another. The difference was where it went, how long it sat, who handled it, and whether pathogens had a route back to food and water. Even the grandest sewer could not answer those questions by itself. When the Western Roman Empire fragmented, Europe did not simply forget that toilets existed. That popular image, ancient Rome has plumbing, then everyone in the Middle Ages throws everything from a window, then the Victorians rediscover cleanliness, is too neat. Medieval and early modern towns used a messy mix of systems. Castles had garderobes, small toilet chambers built into walls, sometimes dropping waste into pits, moats, or channels below. Ordinary households used privies, shared latrines, chamber pots, and cesspits. Town governments issued rules about where waste could be dumped, because disputes over sewage were constant. The problem was not ignorance. It was scale, money, and labor. A cesspit works until it fills. Then someone has to empty it. That someone was usually not the person who owned the nicest room in the house. In London, workers later known as gong farmers, nightmen, or night soil men, emptied pits after dark. They shoveled human waste into tubs and carts and hauled it away, sometimes for use as fertilizer. The work was foul, dangerous, and low status, but cities depended on it. Before the sewer became a machine for moving waste, people were the machine. This is one of the hidden rules of sanitation history. Whenever a society makes dirt disappear, look for where it goes and who has to touch it. For centuries, the answer was often a worker. Waste removal was also an economy. Night soil could be sold. Urine could have industrial uses. Ash, food scraps, animal manure, and human waste all moved through networks of collectors before modern municipal garbage and sewer departments separated those streams into different services. That older system had one advantage modern people rarely notice. It made the labor visible. A household knew when the pit was full because somebody had to be paid to empty it. Flush plumbing changed the psychology. Once waste vanished through a pipe, users no longer had to know who handled it or where it went. Convenience created distance, not only from feces, but from responsibility. Then, in 1596, an English courtier named John Harington published a strange little book with an even stranger title, A New Discourse upon a Stale Subject, called The Metamorphosis of Ajax. It was partly satire, partly political attack, and partly a description of a flushing water closet. Harrington's design used a raised cistern. Release the water, and the contents of the bowl were washed into a lower container or drain. He built a version at his home. A similar device was associated with Queen Elizabeth I. This is often presented as the invention of the flush toilet. It was not. People had used water to carry waste long before Harrington. Ancient drainage systems had already explored versions of the same basic principle. What Harrington produced was an important early modern European water closet, one that clearly described a mechanical flush using stored water. And it did not take over the world. Why would it? A flushing toilet is almost useless without reliable water, pipes, drainage, and somewhere for the waste to go. In a city of cesspits, adding a large volume of water can make the pit fill faster. In a house without a dependable pipe supply, every flush means carrying water in. Harrington had invented an impressive interface for a system that mostly did not exist yet. The next decisive improvement was much smaller. In 1775, the Scottish watchmaker and inventor Alexander Cumming received a British patent for a water closet that included a curved trap in the outlet pipe. The shape forced a small amount of water to remain in the bend after each use. That standing water created a seal. This is the ancestor of the S-trap and P-trap under modern plumbing fixtures. And it solved a problem that had made indoor toilets deeply unpleasant. Without a seal, a pipe connected to a cesspit or sewer is also an air passage. Odors and gases can travel backward. Put water in a low bend, and the pipe is still open to liquids moving through it, but closed to ordinary airflow. The key technology was not flushing harder. It was leaving some water behind. 3 years later, Joseph Bramah patented another improved water closet using a hinged valve arrangement that sealed the bowl more effectively and worked better than some earlier designs. Over the next century, plumbers, potters, engineers, and manufacturers kept refining valves, traps, cisterns, ceramic pans, and siphons. This is where the modern toilet starts to look less like an invention and more like an ecosystem of small improvements. One person improves the seal. Another improves the valve. Another makes the ceramic smoother. Another makes the flush more reliable. Another standardizes the pipe. Then mass manufacturing makes the whole thing cheap enough to leave palaces and enter middle-class homes. The shape of the bowl also mattered more than it seems. Rough. Jointed surfaces hold residue. Cracks leak. Complicated valves jam. 19th century manufacturers increasingly used glazed ceramic because it was smooth, durable, washable, and could be molded into repeatable forms. Better pottery did for toilets, what better metallurgy did for engines. It made a clever mechanism reliable enough for ordinary use. Standardization mattered too. A toilet cannot become infrastructure if every plumber invents a different pipe diameter, joint, trap, and connection. Building codes, municipal rules, manufacturing standards, and inspection gradually became as important as the fixture itself. The bathroom was becoming a regulated interface with the city. By the 19th century, Britain had the conditions that earlier flush toilets lacked. Cities were enormous. Piped water supplies were expanding. Industrial ceramics could produce durable sanitary ware. Plumbing became a specialized trade, and public health reformers were increasingly obsessed with the filth of fast-growing cities. In 1851, at the Great Exhibition in London's Crystal Palace, sanitary engineer George Jennings installed public flushing toilets for visitors. People paid 1 penny to use the facilities, which came with amenities such as towels and grooming services. More than 800,000 uses were recorded during the exhibition. That number matters because it marks a cultural shift. The water closet was becoming public infrastructure. It was no longer merely a rich person's curiosity hidden in a country house. Thousands of ordinary visitors encountered a clean-managed flushing facility at one of the largest public events in the world. But even this progress revealed who cities were designed for. Victorian public toilets were provided far more readily for men than for women. That was not a minor inconvenience. If a city gives one group safe places to relieve themselves and denies them to another, it quietly limits how long people can travel, work, shop, or remain in public space. A toilet can shape freedom of movement. There was another lesson hidden in the Great Exhibition. Public sanitation is not just about disease. It is about participation. A person who cannot reliably find a toilet plans life around that limitation. Long journeys become harder. Work shifts become riskier. Pregnancy, menstruation, disability, age, and illness make the problem more urgent. That is why the unequal provision of Victorian public toilets for women mattered. The built environment was quietly deciding who could remain in public comfortably and for how long. Toilets look private, but access to them has public consequences. A city reveals its assumptions about citizenship in places as ordinary as a restroom door. And then the great paradox arrived. The flush toilet worked. That was the problem. As water closets spread in London, more human waste entered drains and sewers. Many of those sewers had originally been built mainly for rainwater and local drainage, not as a complete system for carrying a metropolis's feces. Cesspits overflowed. Household connections multiplied. The waste moved more efficiently away from wealthy homes. And much of it ended up in the River Thames. The toilet had made the bathroom cleaner by making the river dirtier. London's population had exploded past 2 million. The Thames was still used as a source of water for washing and, through water companies, drinking. Human waste entered the river. Water came back out. That loop was deadly. Cholera had struck London repeatedly beginning in the 1830s. Most doctors and officials still accepted some form of miasma theory, the idea that disease spread through foul-smelling air. The theory made intuitive sense. Places full of rot smelled terrible, and people there often became sick. The correlation was real. The mechanism was wrong. In 1854, physician John Snow investigated a severe cholera outbreak around Broad Street in Soho. By mapping deaths and asking where victims obtained water, he linked the outbreak to a public pump. He persuaded local authorities to remove the pump handle. The famous story is often told as if that single act stopped cholera instantly. In reality, the outbreak was already declining. Snow's deeper achievement was the evidence he assembled, showing that contaminated water, not simply bad air, was carrying disease. London still did not transform overnight. 4 years later, smell did what epidemiology had not yet fully accomplished. The summer of 1858 was hot and dry. The Thames fell low. Sewage and industrial waste baked along the exposed banks. The odor became so powerful that it invaded the Houses of Parliament. Curtains were treated with chloride of lime. Politicians discussed escaping the building. The crisis became known as the Great Stink. And here is the historical irony. The smell that finally forced Parliament to act was not the thing causing cholera, but it pushed government to build infrastructure that helped stop cholera anyway. Engineer Joseph Bazalgette and the Metropolitan Board of Works created a vast system of intercepting sewers. Instead of letting countless local drains discharge directly into the central Thames, the new network collected sewage and carried it farther downstream, aided by pumping stations where gravity needed help. Embankments along the river concealed major sewers and reshaped London above them. This was not yet modern sewage treatment. London was still moving the problem downstream. But location matters. By separating dense neighborhoods and drinking water intakes from concentrated human waste, the system dramatically reduced exposure. The toilet, at last, was becoming part of something larger than plumbing inside a building. It was becoming part of public health infrastructure. And that distinction changes the entire history. A flush toilet does not destroy waste. It adds water and transports it. A sewer does not destroy waste. It concentrates and moves it. If the pipe ends in a river beside another town, you have built an extremely efficient machine for exporting disease. The final step is treatment. During the 19th and early 20th centuries, engineers experimented with settling tanks, filtration through soil and gravel, sewage farms, chemical precipitation, and biological processes. Then, in Manchester, two researchers named Edward Ardern and William Lockett developed a method that became one of the foundations of modern wastewater treatment. In 1914, they described what came to be called the activated sludge process. The idea sounds almost backwards. Instead of trying to sterilize sewage immediately, you deliberately cultivate communities of microorganisms in it. Air is pumped through wastewater. Bacteria and other microbes consume dissolved organic material and form flocks, tiny biological clumps. Those clumps can settle out. Some of the active sludge can then be returned to the process to keep the microbial community working. The toilet began as a way to get away from microbes. Modern treatment learned to recruit microbes. That is one of the quieter revolutions in engineering. Today, a conventional sewered toilet can be connected to a treatment chain that screens out large objects, settles solids, uses biology to break down organic pollution, removes nutrients where needed, disinfects water, and processes the remaining sludge. But that is only one branch of the family tree. Most humans do not need a giant underground sewer beneath every street in order to have safe sanitation. Septic tanks can contain and partially treat household wastewater on site. Pit latrines can safely isolate excreta when correctly designed, located, maintained, and emptied. Pour flush toilets use much less water than many cistern systems. Twin pit systems can allow one pit to rest while the other is used, giving waste time to decompose. Composting and urine diverting toilets can work where water is scarce or sewer construction makes little sense. Water itself now forces another rethink. The classic cistern flush was developed in places where engineers increasingly assumed that large volumes of clean water could be delivered to buildings and large volumes of wastewater could be carried away. That assumption does not fit every climate, every settlement, or every century. In water-stressed regions, using drinking quality water to transport excreta can be an expensive bargain. In flood-prone regions, pits and tanks can overflow if they are badly sited. In dense informal settlements, there may be no room for conventional septic systems and no municipal sewer to connect to. A technology that is excellent in one landscape can fail completely in another. The future of the toilet may therefore look less uniform than its recent past. Some systems will use less water. Some will separate urine. Some will treat waste close to where it is produced. Some will recover nutrients or energy. The goal is not to copy one porcelain design everywhere. The goal is safe separation. This corrects another modern misunderstanding. The most advanced toilet is not automatically the one that uses the most water. A toilet is successful if it safely separates people from feces through the entire sanitation chain. That phrase, entire chain, is crucial. Capture. Containment. Emptying. Transport. Treatment. Safe disposal or reuse. Break any link, and a beautiful porcelain fixture can become little more than a delivery device for contamination. The human labor in that chain has not disappeared either. Modern sanitation workers empty pits, maintain septic tanks, clear block drains, inspect sewers, operate pumping stations, and run treatment plants. When the work is mechanized, regulated, and protected, it can be done far more safely than the night soil work of the past. When workers are forced into pits or sewers without proper equipment, toxic gases, collapsing structures, pathogens, and drowning can still make sanitation deadly. The machine still has people inside it. And the global story is not finished. According to WHO and UNICEF estimates for 2024, about 58% of the world's population used safely managed sanitation. That means 3.4 billion people still lacked it. Hundreds of millions relied on limited or unimproved services, and about 354 million people still practiced open defecation. Those numbers tell us something uncomfortable about the word invented. Humanity knows how to build safe toilets. The remaining problem is not simply technical knowledge. It is infrastructure, water, land, maintenance, inequality, governance, behavior, financing, climate, and whether the people who clean the system are treated as essential workers rather than made invisible. So who invented the toilet? No one. And almost everyone. People in ancient Mesopotamia learned to isolate waste in pits and drains. Urban builders in the Indus Valley integrated household, washing and drainage into planned neighborhoods. Greeks and Romans expanded water-fed latrines and sewers. Medieval cities relied on pits, privies, regulations, and the brutal labor of people who carried waste away by hand. John Harrington demonstrated an early modern mechanical flush. Alexander Cumming trapped a small pool of water in a bent pipe. Joseph Bramah improved the working mechanism. George Jennings helped turn the water closet into a public utility. Bazalgette connected buildings to city-scale infrastructure. Ardern and Lockett helped teach cities how to biologically treat what the pipes carried away. The toilet was invented in layers because the problem itself has layers. First, get waste away from the body. Then get it away from the house. Then stop the smell and gases from coming back. Then move the waste without exposing workers and neighbors. Then keep it out of drinking water. Then treat it before returning water and nutrients to the environment. Miss one step and the solution can create a new problem. That is exactly what happened in Victorian London. The flush toilet was a triumph inside the home and a disaster at the scale of the river until the rest of the system caught up. Which brings us back to that small pool of water in the bowl. It is easy to think the important moment happens when you flush, when everything disappears. But the more revealing moment comes afterward. The bowl refills. A little water remains. On one side is the room where you brush your teeth, wash your hands, and begin your morning. On the other side is a network carrying the biological waste of thousands or millions of strangers. Between those two worlds is a simple liquid seal, backed by 5,000 years of pits, bricks, pipes, arguments, epidemics, labor, chemistry, and public engineering. The toilet is not the machine that makes waste disappear. It is the agreement that waste has somewhere safe to go.